So Kruskal-Wallis test. So the next test usually is the Kruskal-Wallis test. So the Kruskal-Wallis test is more or less an alternative to the ANOVA, and use the ANOVA for 3 or more group. So it's supposed to be 3 or more group here, not 2 plus or more group. So when you want to compare distribution across 3 or more groups, you consider the ANOVA. So how does it actually work? First of all, you pull all the observations and rank them, similar to Van Whitney. Calculate the sum of the ranks for each group. You compute the age statistics based on rank sums. So age statistics has a formula. I just decided not to put it here. And you compare that particular age statistics to a chi-square distribution. And if it is significant, you conduct post-hoc tests, just like we did in ANOVA, to find out which particular variable is significantly different from the others. So the assumptions of the Kruskal-Wallis is that there have to be 3 or more independent groups. The observations are also independent, and your data is at least ordinal. Then for comparing medians, similar distribution shapes across the groups. So it handles unequal sample sizes very well. So all groups should come from the same distribution. That's the null hypothesis. And alternative hypothesis is that at least one group differs from the others. So it does not specify which groups differ. That's what you should know. You need to go conduct a post hoc test for this. And also it tests for any distributional difference, not just the location. So the H statistics is actually the statistics that you get from the Kruskal-Wallis test, which approximately follows the chi-square distribution. So degree of freedom is k is equal to k minus 1, which is k number of groups. Larger H values indicate greater difference, and we have adjustments for ties. So tied ranks are averaged, and correction factor usually applied to the H statistics. For the post hoc testing, if the Kruskal-Wallis is significant, then you conduct a post hoc test. Popular ones are the Dunn's test. So pairwise comparison with multiple testing correction. We have the pairwise Van Whitney with Bonferroni or other corrections. We also have the Canova test. This is also a more powerful alternative. So multiple testing correction is usually needed for you to control type 1 error. So an example scenario of a Kruskal-Wallis is when you want to compare the pain relief scores across 4 drug doses. So we have 4 drug doses, and you want to compare. If you have 2, you can just decide to go for your Van Whitney U test. But if you have 4, it's better you go for the Kruskal-Wallis. So ordinal scale usually 0 to 10, no relief to complete relief. So we have 30 patients per dose group, and the data is ordinal and skewed. So why do you consider the Kruskal-Wallis test? Because we have more than, in this example, we have more than 2 groups, 4 doses, the ordinal outcome measure, and also we're interested in overall dose effects.